Hi, I'm going to solve the partial 1 exam of Physics 2. The first problem says like this. Donald Duck and his nephews managed to sink Uncle Scrooge's yacht with a mass of 4,500 kilograms, which is made of steel with the density of the steel, it's 7,800 kilograms meters cubed. In typical comic books fashion, they decide to raise the yacht by filling it with ping pong balls. Here we have ping pong balls. A ping pong ball has a mass of 2.7 grams and a volume of 3.35 per 10 elevated at the fifth potential meters cubed. First of all, we have to guess what is the buoyant force. Well, not guess, calculate the buoyant force on one ping pong ball in the water, and then we have to calculate how many ping pong balls are required for floating the ship. So first of all, I'm going to analyze the part of floating the ship, and then I'm going to go to the buoyant force. As we can see here, it's the ship that it's already sink. And we have all that information according to the ship, okay? We also have to know that the buoyant force it's equal to the quantity of to the buoyant force of the quantity of balls and the buoyant force of the ship, because the mass it's considering the ship and the balls. So here we can say that the buoyant force, the total buoyant force, it's the sum of both buoyant forces from the balls and from the ship. So here we can say that N, that it's the number of balls that it's needed to sink the ship, times the density of the water, that it's the fluid, times the volume of the ball, times gravity. This is the buoyant force of the balls, plus the density of the water, times the volume of the steel, times the gravity. And this is the buoyant force of the ship. Once we have this, we can equal this to our diagram of forces. We can say that here there are some forces from the balls, and we also have forces of the ship. So we can say that the buoyant force also it's equal to the mass of the steel plus the number of balls, mass of the balls, times gravity. So here we are using our forces in the diagram. We're placing them here. Okay? Now we have this equation. So we have to solve it in order to obtain N. And we can say that the N, the density of water, it's 1,000. The volume of the balls, it's 3.35 times 10. Here we are using it in meters, in kilograms over meter, but we can use it in grams over centimeter. But no, we're gonna use it in kilograms over meter. This, well, here we have the gravity. It's included in the three terms, so we can get it out. So, as I was saying, here we have to add the density of the water times the volume of the steel, and as we can see, the volume of the steel it's equal to the mass over the density. So here we put the mass over the density to obtain the volume, and this will be equal to the mass of the steel, that is 4,500, plus the number of balls times the mass of the ball, that is 2.7 per 10 minus 3 kilograms. And as we can see, we have only here one value that it's not seen, that it's the number of balls. As we get out of the equation the number of balls, we get to obtain that we have to use 127,373 ping pong balls in order to float the yacht. Now, for getting the buoyant force of one ball, here we gonna go, the buoyant force of the ball, it's equal, as I said, to the density of the liquid, of the fluid, times the volume displaced, times the gravity. Here is the formula of the buoyant force. And as we can see, we have the density of the water, we have the volume of the ball, that is this one, and we have finally the gravity, 9.81. So once we have these, here we can obtain that the buoyant force for one ball, it's equal to 0.3286 newtons. And this is how you solve problem 1.